Today we are starting on the last lesson in Unit 4. We're going to spend one day focusing just on problems involving trig, and then we'll spend another day involving trig, sine, and cosine graphs. All on the front, we've seen these actually, I think back in the very first part of this unit. It's really just setting up some right triangles. The focus here is on angles of elevation and angles of depression. I found a picture just cut and pasted from a textbook, and also some definition. So the angle of elevation is always looking at the horizon and then above that horizontal line. So in other words, if you're standing here and you're looking out and you're looking up, you're looking at an angle above the horizon. If you're looking at your angle of depression, you're looking out and you are looking below the horizon. 1 and 2 are pretty straightforward, back to what you've seen in even geometry. So taking a look at number 1, it says Brian's flying a kite at the end of 65 meters of string. They tell you what the angle of elevation is, so let's go ahead and draw that picture. We've got 70 degrees. It tells us the kite. So up here is our kite. This is 65 meters. They want to know how high is the kite above Brian's head. So they're looking for this height right here. This is where Brian is, but this would be its corresponding distance, so we're looking for that length right there. We have opposite over hypotenuse. We're going to use sine. Sine of 70 degrees equals x over 65. We're going to plug this in your calculator. Make sure you have it set to your degree mode. And we'll go ahead and type that in. Okay, I went ahead and typed this in on my calculator. I ended up with x equals 61.08 meters. Let me give you a chance to look at number 2. Okay, I went ahead and set up number 2 and solved it. See if you came up with the 59 or 15.92 as well. Alright, 3 and 4, we saw one similar to this at the beginning of the unit, but it's been a while. It says you have a plane, and I'm not going to do a very good job. It's flying due east at 265 meters above sea level. As I know, this is 265. It has 2 different angles of depression looking at 2 ships down below. So I'm just going to put S number 1, S number 2. So again, we're looking out and down at ship number 1 and ship number 2. So the first ship only has a 25 degree angle of depression. So if you can envision, this is our picture here, which means we've got 265 here. Then my second one, this angle is 35 degrees. And again, if I was to draw it in, I've got 265 there. They want to know how far apart are the ships. So ultimately, we're looking for this distance down in here. I'm going to focus on this triangle up in here. I have opposite, and what I'm actually going to do is find this length right here, which is the adjacent. That would give me this distance, which gives me this total distance down here. In other words, I see tangent of 25 degrees equals 265 over x. We're going to go ahead and solve that in just a second. My second right triangle I see is my 35 degree angle. And again, we've got 265. I'm going to go let that distance in here be equal to y, which would be there. We've got tangent of 35 degrees equals, again, that 265 over y. We're going to go ahead and solve that. Plug those in my calculator real quick. I'm doing 265 divided by the tangent of 25. We get 568.29. 265 divided by the tangent of 35 and we get 378.46. So I figured out this distance is approximately 378. This distance here is approximately 568. So I'm going to go ahead and subtract the two to figure out the distance between those. When I do that, I get their final distance is 189.83 feet. Actually, this is meters apart. Let's go take a look at number 4. It says Tom and Sue are opposite sides of a tower, so I'm just going to label this to be my tower. It's 160 meters high. They measure the angle of elevation as 40 and 50 respectively. So in other words, we have Tom here, and when he looks up, he sees the tower at a 40-degree angle. When Sam looks up, he sees this as a 50-degree angle, and we want to find the distance between them. Again, I'm going to let this distance between Tom and the tower be x. This distance between Sam and the tower be y. We're going to set up two trig equations. We've got opposite over adjacent again, meaning we're going to use tangent. Tangent of 40 degrees equals 160 over x. We'll solve that here in just a second. On the flip side, let's go do Sam. Tangent of 40 degrees equals 160 over y. Again, we're going to go and solve that for y. First distance I'm getting is 190.68. The second distance I'm getting I forgot to change this angle in here to 55 degrees. Let's try that again. 112.03. We can add those together, and really if we want to be a little bit more accurate, let's go ahead and talk about, we could type this all in exactly how we see it. In other words, when we solve for x, we're doing 160 divided by the tangent of 40, and we're adding on 160 divided by the tangent of 55. That'll give us a little bit more degree of accuracy. Finally, we end up with 302.71, and in this case, again, we're talking meters. Alright, moving on to the back side then. The second set of problems are dealing with bearing and navigation, and I gave you just a few notes that I found in a textbook to hopefully help you out as well. Let's take a look at number 5. It says an airplane flies on a course of 110 degrees at a speed of 120 kilometers per hour. How far east of its starting point is it? So let's draw a picture to begin with. 110 degrees bearing, so this would be 90. And then when I add that on, I end up with 10 more degrees. And its speed was 120 kilometers per hour. If I take 1,200 kilometers times 2, that means they've traveled 2,400 kilometers. So I know this length is equal to 2,400. All I want to know is how far east. Well, that east distance would be represented by that length right there, my x-coordinate. Now we're back to some right triangle trig. We have adjacent over hypotenuse. That would be cosine. So cosine of, my math is terrible this morning, this would be cosine of 20 degrees, because that would be 90 minus 110 would give me that extra 20 degrees. Cosine of 20 degrees equals x over 2,400. Let's go ahead and type that in. And this would be kilometers. Here's the picture I came up with on number 6. Here is the plane. They're heading to the airport. They're 160 miles north, 85 miles east. I'm going to go look for this angle here. Opposite over adjacent is tangent. Tangent of theta equals 85 over 160. Anytime we're looking for that angle, we are doing inverse tan, or inverse of that function. And to the nearest degree, I've got 28 degrees. But remember, if we're talking bearing, it has to be with respect to north. So I'm going to come down here, just draw another little picture for myself. So here's the plane. I got to figure out the 28 degrees is just this angle in here. Remember, bearing starting from the north and coming all the way to here. Well, this degree measure would be 280 plus that 28 degrees, and we end up with 308 degrees. And I don't know how I got 280. Let's try, it should be 180. This would be 180 plus the 28, ends up putting us at 208 degrees. Let's go look at number 7. It's similar. It says a ship is 70 miles east and 40 miles south of a port. So 70 miles east, 40 miles south, and he wants to go directly to the port. So again, here's the port, here's the ship. First thing we're going to go and do is find this angle in here. We've got tangent of theta equals 70 over 40. I'm going to go and do inverse tan. 60 degrees. But again, remember, if we're talking bearing, we're starting here for that ship, and we are going all the way around to here. So if I went all the way around, I'd be 360, but I'm short of that by that 60 degrees. So we're going to take 360 minus the 60 degrees, and we end up with approximately a 300 degree bearing. Okay, last one's a little bit more complicated, and this one actually I found in your book. I'm going to give you a second to pause, just kind of read through it. Alright, taking a look at the last one. First of all, I went ahead and did 35 knots times the 2 hours gives me 70 knots from here to here. 35 times 3 hours gives me 105 knots from here to here. I went ahead and pulled out that triangle. You might be asking, how do I know that's the right angle? If this is 53 degrees, these angles are alternate interior, so this is 53 degrees as well. This forms a straight line, which is 180, so 180 minus the 143 is 37. When you add those together, you get a 90-degree angle, which makes sense because remember, all of these are in the context of trig, which is based on right triangles. First thing they want me to do is find that distance. We're just going to go and use Pythagorean's theorem. And when I do that, I end up with 126.19 knots. The second thing they want me to do is find the bearing with respect from Port Cleveland. So in other words, I am looking for this angle right here. Again, opposite over adjacent. That angle is going to equal inverse tan of 70 divided by 105. Alright, re-looking at the problem, here's the angle that eventually we're looking for, because this is where the ship truly ends up. So we should have done inverse tan of 105 divided by 70, which is 56.3, which is this angle, but then I'm adding on that 53-degree angle, because that is from north. When I finally add those together, I get 109.3 degrees. Tonight's assignment is on Excel. I think there's about 15 or 16 questions. Send me a message if you have any issues.